love to see you there as a member of the public. And then the Bethany Sustainability Committee. And then also, on the town, we are working on food waste diversion. So, for those who compost, or for those who want to separate their food waste, but perhaps don't have the ability or desire to do it in their backyard, we are working with a company to find ways to do this not in your backyard. So, you'll see in the back there's a green bucket. Blue Earth Compost is who we work with at Beecher Road School, and who we're working with to try to get residential pickup here. If anyone's interested, you can sign up on their website. And then once we get 50 signatures, we will be able to have pickup here. And today, I have the very great pleasure to announce we are starting a Heat Smart Woodbridge campaign. And we have Allison from the town hall here to bring us into it.
Oh, look at you put this together so quick. That's awesome. I didn't see it get it for you. So good afternoon, everybody. On behalf of the First Selectman's Office in the town of Woodbridge, I wanted to be here today to officially launch our Heat Smart Woodbridge campaign on account of already having this incredible lecture series scheduled on heat pumps. Today felt like a perfect day to align those two missions and visions. I also want to thank the Woodbridge Sustainability Committee as a whole. Their commitment and the work that they put in have produced initiatives like this. Earth Day, which I'm already looking forward to April. We'll be planning that soon. The food diversion program for residents. There's so much work that they do behind the scenes. It's something that we know. I would like Woodbridge to be an example of what's possible when we bring education to the residents and we work as a community to be more sustainable and all of those things. And Heat Smart Woodbridge is a really great opportunity to do a lot of those things. So it's an education program. It's a marketing campaign. It's about to raise awareness and also to drive us as a community to all focus our efforts together on making our homes more energy efficient, like one at a time. It makes the process really simple. It's going to connect our residents with the resources that they need to have their home energy solutions, home audits, to make some real impactful, simple changes that will immediately have some cost savings. And I'm hoping it's something we can work together and bring more of our residents in together and work collectively as a community for a more sustainable future. So with that, I'm going to turn it back over to Hillary.
All right, so check out this QR code.
We do have our own website for Woodbridge residents to go to. We'll be updating it with upcoming events, future events, more ways for you to get involved in the process. And if you guys ever need anything or there's any questions, you can always contact us at Town Hall in the First Selectman's Office, or our Sustainability Committee is happy to answer any of your questions. So
this is going to be all sorts of things, like getting your home energy audit. Has anyone done that? Let's just show of hands. Who's done a home energy audit ever? Okay, so I see a lot of hands not raised.
Mine, I will be. I haven't yet, and I will be.
So it's an eye-opening experience. If you have not done it, you call this number. So first things first, go to the QR code, call the number, set up your home energy audit. It's either free or $75, and they come and they sort of tell you how efficient your house is. And then they'll do certain fixes for little things, drafts, and then they give you the best thing about this. They do a bunch of work themselves, which is amazing. And then they also give you a book of rebates afterwards. And so that's for energy efficient appliances, solar panels, insulation, heat pumps, thermostats, what other fun? I don't know, a lot of things, honestly. And I believe one of them, I'm in the process of finishing my part, one of them that I still have to do is, I think if you do anything, you send in the rebate and get the $75 back.
I think the service itself is rebated.
Yeah, you get the $75 back, actually. So I have to do that first. So you can actually get it for free if you just do something. Just do something.
Also is available for free based.
It's income based
as
well. So if for some reason you know someone who is receiving other services, it's likely they can do this for free as well. But again, everybody can do it. Just do something, you get it. So it's a great service. Then that puts you in touch with many, many other wonderful resources and amenities that you can do to make your home more energy efficient, cheaper to heat and cool and live. So highly recommend it. All right, and with that, let us talk about heat pumps. So Massaro and Woodbridge Sustainability, Bethany Sustainability. All welcome Matt from Energize CT here to talk about Heat Pumps 101. And my one last plug here is look at our other lectures that are coming up. We'd love to have you. December is going to be, we're going to do an upcycling for gift making and giving. And then talking more about energy audits in the future, recycling, composting, and then April 26th, Saturday, mark your calendars, Earth Day. We want to know what you want to see. Email us, tell us afterwards. We want to know what you want to see at Earth Day. We want to see you there. All right? Without further ado, welcome Matt.
It's on.
Okay.
Yeah. Alright, so hey everybody, well I'm getting my presentation up here. Oh. Alright, great. So, my name is Matt. I'm a heat pump specialist with Energize Connecticut. So, I'm here today to talk about heat pumps, and we'll all learn a little bit, hopefully. And I do want to do a little survey of the room first while we're getting started. Maybe we'll do this today. Here you go. All right, awesome. Okay. So, talk a little bit about Energize Connecticut. We'll talk about heat pumps. Why would someone want to consider a heat pump? And then we'll talk about incentives and home energy solutions was just mentioned. That was one of them, so we'll go over that, more details about that. So, what is Energize CT? Does anyone know what Energize CT is already? Everyone here? Okay, so you guys are pretty. A lot of people that the energy test can probably do. So really, like we're just like the utilities energy programs, right? So you guys are electric customers of mostly UI here, right? Any Bethany people of Eversource, right? Yeah, okay. And so you pay into the fund that funds all these programs. So we have rebates and stuff we'll go over, as well as education like this, and try to help you make smart energy choices with your home. That's really cool. So. Heat pumps, talk about heat pumps. So at the most basic level, a heat pump is an all-electric heating and cooling system. So, hey, how you doing? You didn't miss much. Sorry. So heat pumps do heating and cooling. It's the same technology as air conditioning. So it's doing the exact same thing. So air conditioners are moving heat with refrigerant. Heat pumps are doing the same exact thing, except they can move heat in both directions. So in the summer, a heat pump is literally doing the same exact thing an air conditioner is doing. It's cooling your home by moving heat outside. Heat pumps in the winter can basically flip in reverse. There's something called the reversing valve in the refrigerant loop, and you can look up reversing valves. They're really cool. You can watch like a minute-long YouTube video, and engineering's very cool. But anyway, they're able to reverse like the flow of the refrigerant in the system and move heat in the opposite direction, so they can heat in the winter as well as cooling in the summer. But they're the same exact thing as air conditioning. It's refrigeration technology. Refrigerators are doing the same thing. They're moving heat out of the fridge box. It's all the same stuff happening internally, just applying it to your house. And in both directions, of course. So there's a few different types of heat pumps. The main two categories are air source heat pumps, which we'll look more in a second. There's also ground source heat pumps. So a ground source heat pump is the same thing as geothermal. Same technology, means the same thing. And the name ground source, like ground source, we just said heat pumps are moving heat, right? So the source, right, ground source implies it's moving it from the ground, and then we'll talk about air source in a second as well, which are moving heat from the air outside. So there's a few different types of ground loops. Here in Connecticut, really these are really all you see, just based on our geology, and our, we've got we're pretty close to bedrock. So you can't really, it's really uncommon to be able to do a horizontal loop field. This is like where they do trench work in the yard versus having a drill rig. So we'll talk mostly about air source today, and we'll talk about design. We're mostly going to talk about inside of the house. But outside, for a ground source system, you don't have anything outside. You have this ground loop, which would be connected like through your basement. So, for ground source, most of the inside the house stuff is similar, so we'll go over that. But for ground source, you've got a ground loop outside. Air source, on the other hand, has an outdoor unit. This is obviously just a little sketch here. We'll look at some real air, some more. They're not real. They're real. You'll see them more definition later. But air source has an outdoor unit, so just like a condenser outside for an AC system, you have an outdoor unit, and same thing for an air source heat pump. And so in the summer, it's doing the exact same thing as an air conditioner, working the exact same way. In the winter, again, they're flipping in reverse, and even when it's very cold out, air source heat pumps can heat homes in our climate. That wasn't always true. So, 10 plus years ago, heat pumps didn't really work so well in freezing temperatures, and that wouldn't work well in our climate because we get a lot of freezing temperatures. But nowadays there are cold climate heat pumps, and so there's still heat pumps that are made for warmer climates, and there's still systems that are installed here that aren't meant to be, the heat source for the whole home all year round. But you can size and design a cold climate heat pump to totally replace another heating system if you want, if that's your goal. So people will talk about goals. People have different goals with heat pumps, but they can do all of the heating for a building in our climate and much colder climates. So a few things happen when it gets cold. So we're talking a little bit about cold climate performance because I know that's a lot of people have heard, heat pumps don't work well in cold temperatures, like we talked about. Not all of them do, but the cold climate ones are built for our climate. So two things happen when it gets colder. So number one, heat pumps get less efficient. So, before we look at that, more on this side. So two things happen when it gets colder. Heat pumps have to work harder, right? So they're moving heat from outside, and when it gets colder outside, there's less heat, there's less thermal energy in the air. So the heat pump has to work harder to heat your home, right? So they're using more electricity per the amount of heat it's bringing in. So they get less efficient, basically. You're getting less heat for the energy you're putting in. What also happens when it gets colder, and this is for some heat pumps, is they lose some of their ability to produce heat when it gets colder. So two things are happening here. Less efficient, all heat pumps are getting less efficient, even the cold climate ones. But standard heat pumps, and these are, not black and white categories. There's, it's a spectrum of performance in cold temperatures, but this is generally how we categorize them. So standard heat pumps, actually both of these heat pumps, when it's 47 degrees outside, can move 30,000 BTUs per hour. So both of these heat pumps, when it's 47 out. But when you look down at their performance at 5 degrees, the standard heat pump actually can only do less than half of its BTU capacity down at 5 degrees. So this heat pump does substantially less heating at cold temperatures compared to the cold climate one, which does all of its rated temperature, all of its rated BTUs down to 5 degrees. And so when it's cold is when you need a lot of heat, right? So if your goal, obviously, is to totally do all of your heating with a heat pump, you definitely can. You just want to look for a cold climate one. That's and the contractor would figure out based on the efficiency of your home and how large it is, right? How much heat you need, and they would match the performance of the unit with your home, right? And we'll talk about there's not everyone wants to totally replace their heating system. We'll talk about dual fuel systems in a little bit. We'll talk about other if you just want to increase comfort in a space. So there's a lot of reasons to get a heat pump, but on cold climate performance, they work great in cold temperatures if it's a system that's built for it, right? I'll pause here. Any questions on this before we move on?
Sorry, I apologize if you're going to get to it, but what's the fundamental difference in the construction of those two homes that allows that to be cold and that to be standard?
Yeah, great question. So a few different things in the engineering, and I'm not an engineer, so I'm not going to get into the real micro design stuff, but in general. So one thing is a defrost cycle. So one of the problems with standard heat pumps, the reason they don't work well under freezing temperatures is that so when a heat pump is heating your house, it's cooling the outside, so it's moving heat from inside from out, and when the coil is cold outside, moisture from the air accumulates on the coil and then freezes if it's under freezing temperatures, and sometimes the coil is even though it might be 40 out, the coil is 20 degrees, so it's going to freeze that the coil, and that like over time builds up ice, and then they can't work as well anymore. So that's one reason that they get worse in cold temperatures. There's also basically the coils and the compress. So one thing is a variable speed compressor.
Okay.
So they essentially can like work harder when they need to, and so standard heat pumps are often single or dual speed. So they're really built to work at one speed, and they when you're expecting a system to work over a range of like 70 degrees from like when it's 0 out versus like 60 degrees out, you're going to be heating in all those hours. So with one speed on a single speed unit, it's not really able to work well at the whole range of temperatures. So when you have a variable speed compressor, which all the cold climate ones do, it gives them a bunch of speeds so they can optimize those speeds for the different temperature range that they expect to see. So basically they're just not built for as wide of a range of temperatures, and I hope that helps.
Oh, yeah, no, that's a lot, thank you. So does that one use more electricity because of that, with like the defrost cycle, and like what's their like energy usage?
Yeah, so like really they're comparable. So we could talk about like data points to look at, but
I'm sorry, I asked a bad question.
I think I've just been stepping on the cord. The defrost cycle does use energy. It takes a performance hit by doing that, but we'll look at a cost comparison when you. No, yeah, I mean it's factored into the performance data when you look at the equipment,
Okay.
and the variable speed aspect of the. I mean, it's not. There are variable speed heat pumps that are not built for cold temperatures, but the variable speed part of it more than makes up the difference. They're like more efficient with those added speeds. Sorry, I'm not sure what that. Yeah, we'll talk about cost to operate and performance as well. So we'll get to that.
Is the wall part? Yeah. Oh.
Okay, yeah, we're back. Anyway, before I move on, we'll start talking about design and stuff. So I just want to, anything else on performance or cold climate performance? I know it's a big sticking point for some. Anything else here? All right, so on design, and before we actually get into this, I want to do a quick survey. So who has their heating done through radiant heating? So like baseboards or you've got the steam radiators. Okay, so like around half the room. And then who's got a forced air system? So you've got like ductwork and stuff. All right, cool. Who's got radiant and cooling through ductwork? Does anyone have?
Oh, no, not radiant.
Like air conditioning and
HVAC, yeah, heating and cooling through ducts.
Okay, cool. Cool. So I just want you to be thinking about your own homes when we're talking about this. And so we'll talk a lot of like general stuff today, and I want you to save your like in your home, how this work in my home questions. We'll walk through a lot of design stuff. Something I'll show you at the end, and there's actually, you can scan a QR code on the paper in the back there, but we do consultations, heat pump consultations with folks, my team does, all for free. We would sit down, it's a virtual meeting, so you can book up to 45 minutes, but usually you can stay longer if you need. Talking about in your home, what might make sense, how to think about design, how to talk to contractors about like what you want. Everyone has different goals, so we'll talk a little bit about goals generally, but like you might want to save money. Someone else really cares about the environmental impact, doesn't care about the money, right? So we'll talk about those things. So okay, so all heat pumps, and so now we're talking about air source mostly, right? But the inside portion is again similar for ground source. But so all air source heat pumps have an outdoor unit, right? So just like a central air system, this is where the heat's exchanged outside, so the outdoor unit. And then connected to that is one or multiple indoor units. So there's like a refrigerant line, there's refrigerant headed between these two, there's also electrical headed between these two, and a condensate line. So for homes that have existing ductwork, so those of you that raise your hand for forced air systems, you can probably use your existing ductwork and put a heat pump in it. So your design is fairly simple. If the ductwork already serves your whole house, you can install a ducted heat pump that would just use the existing ductwork. So it's a relatively simple design. Ductless units are great for homes that don't already have ductwork. You can even do a combination of these two, so you can have multiple duct indoor units and they can be ductless in parts of the home and ducted in other parts of the home. So there's a lot of versatility with these systems. You can design it almost for any home, and there's advantages of either. So if you don't already have ductwork, we'll talk about this a little bit. So a little more on ductless, right? So you've got wall-hung units, and a lot of people call these mini splits. So you've probably heard that term. Ductless, mini splits, same thing. So you can use them interchangeably, basically. The split comes from actually the outdoor and indoor unit, so that's like the split. So really these are all like mini splits, but it doesn't matter. Wall-hung units, so these are really the most common. Floor-mounted units and ceiling cassettes are awesome too. They have like different aesthetic impacts in the home, so a lot of people prefer those designs. If you're getting installed, these would cost a little bit more than these, like per head, but it's not a huge difference. But inside, they're all exactly the same. They're doing the same thing. This is where the heat's exchanged inside, right? So you've got the outdoor unit connected to one or multiple of these, and the placement matters. And where these really shine best, they can work anywhere in a home, but where they really shine best is like more open spaces where one unit, and they come in all different sizes. One unit can do a pretty large space all on its own if it's, because they have louvering fins on them that blow air in multiple directions, up and down. So they can serve a pretty large area if they're sized for it. So if you've got like an open floor plan, kind of like kitchen, living room, dining room area, you might be able to do, if it's positioned in the right way, do that whole space with just one of these. So that's where they work best.
Real quick.
Yeah.
Going back. So let's say the floor mount.
Sure.
What would be typical, and how many of those would you? Obviously, the floor plan the spaces, but 2,000 square foot, floor, or 1,500 square foot floor.
Yeah. So for sizing the system, so the outdoor unit size for the whole home, right? Or for larger homes, you might need 2 separate systems. But for like a 2,000 square foot home, you're probably okay with just one outdoor unit. The indoor units are sized for the zones they're in, right? So they would decide like, okay, this area we're gonna have responsible for this indoor unit, and this other room we're gonna have on a different one, right? And so the contractor would figure out, they should do what's called a heat load calculation, and that's what takes into account, another like the technical term for that is called a manual J. And basically what they should do is figure out, based on the size of the home, the layout, how efficient it is, so like how well sealed and insulated the building is, how much heating you need, right? So it's, and if you think about your example here, and this is why it's difficult for me to give you an answer, is because you can have a 2,000 square foot, 1,700 built barn house, or you could have like a brand new building that was just built in 2020 with like, the energy code we have today, which is, very efficient. So it's difficult to say.
Yeah, I figured.
But like generally like 300 to 600 square feet per ton of heating, and the tonnage is like the BTU capacity. And these come in all different sizes, so they come in half tons, 1 ton, 1.5, up to 2 tons per indoor head. And so like they would size the indoor head to what you need and figure out what that space needed, right? And like sunrooms will need more heating than like like a home that doesn't have a lot of exposed walls or windows or whatever. So anyway, it's all dependent, and any of this is like something too when if you talk to contractors, if they say, oh, I'm just gonna, I'm just ballparking it, or I know what you need, I don't need to do a heat load calculation, that's not a good sign, right? You should push for that when you're talking to contractors. We'll talk about that later, but sorry, I know that was a great answer. But.
No, that's fair. I didn't expect a very,
Yeah. But schedule a consultation, we could talk.
Just to get some kind of idea.
Yeah.
And in your non-answer, I learned a lot.
Great. Great. I'm glad I like that. All right. So for ducted systems, right, where we talked about if you have a centrally ducted home already, awesome, you're in good shape. You probably don't have to make any changes to it. Ductwork that was designed just for cooling. So if you have cooling only ductwork right now, homes in our climate need more heating BTUs than cooling BTUs because we have more extreme winters and summers. So sometimes there are challenges taking cooling only ductwork and then you want to do heating and cooling with it. So it kind of depends a little bit in that scenario. But most of the time it's just fine for existing ductwork. compact ducted systems are really cool. So it's like the same, these are the same thing, this is just smaller. And those are really great for like multiple small bedrooms. So like a lot of homes in New England style homes, colonial style homes will have, you know, bedrooms upstairs, 2, 3, 4 bedrooms upstairs with an attic space. So you can do a compact ducted unit in the attic just serving those bedrooms, because that, you know, you don't have to put a ductless head in every room, and sometimes it's actually cheaper to do that than spend money on 3 or 4 of these guys for each bedroom. So, you know, compact ducted systems are great where you've got like more compact floor plans or smaller individual rooms. And you can do a combination of those two. So again, a lot of versatility here. So, you know, the most simple design is a single zone unit. This is, you know, something like this would be great for like if your living room's uncomfortable, or if you don't have cooling and you just want to get cooling like this, the common area of the home. This is a really great, easy, cheap solution for that, or I should say inexpensive. Multi-zone systems, you can do a whole home with one of these. So usually you can do like up to 4, sometimes 5 units on one outdoor unit for a multi-zone. So these are like this is a ducted air handler, but you can have you know, ducted or ductless, and you know, and this is a really this is like some systems can go up to 8 with a branch box. These are branch boxes that are, you know, add some cost to the project, but yeah, you can do a lot with these. And my goal here is not, you don't have to design your own system. So you know, don't go back. You have to like scribble out the design and everything. Don't worry about that. The contractor will do that. You know, when you get quotes and you can talk over the design with them. My goal here is to give you enough information to where you could like ask good questions when you're talking to them. You know, thinking a little bit about the design so you could know what they're talking about when they're suggesting stuff. That's my goal here. We're going to jump off of design on this in a second. So any questions on design? In general, not about your house, sorry. Alright, cool. Alright, so why would you want to consider a heat pump beyond what we talked about or anything else? So the ability to heat and cool in one unit. This is nice. You can simplify your home a little bit. You know, you don't have to have AC, and then you have to worry about maintaining 2 pieces of equipment. It's all in one. If you're at a point with your home's equipment life cycle where your furnace and your air conditioning are both at end of life or near end of life, you can replace them both with one system. So that's often cheaper than buying 2 new pieces of equipment. And so heat pumps are great for that reason too. So if the life cycle of your equipment, heating and cooling, are both nearing end of life, it's a good time to consider a heat pump. And the best time to do a heat pump is always when you need to replace stuff anyway, right? So all this stuff is not cheap. We'll talk about incentives and stuff later, but heat pumps aren't, you know, no heating and cooling system, new ones are expensive, or are inexpensive. They're not, none of them are expensive. So the best time to do is when you need to replace something, but even better when you need to replace 2 things. Lower heating and cooling costs. So we'll look at in a second about cost comparisons with heat pumps and other types of heating systems. But in a lot of cases, you can save money switching to a heat pump on your annual heating and cooling cost. And reduce carbon emissions. Obviously, this is, you know, important. You know, some people aren't in a privileged position enough to value this in comparison to like the other things here. But yeah, for a lot of people, this is really important as well. And we'll look at carbon emissions comparisons and save a lot in your annual emissions. Okay, so I have a more complicated graph that we're not going to take a look at here because it's more difficult and harder to see because it's pretty intricate. But this is in general. So what we did here was we took, you know, just an average Connecticut-sized home. If you look up like the Realtor.com data, this is like the average, right around 2,000 square feet Connecticut home. And if you heated that home for the whole year in an average year, so 10 years of historical weather data, and we took 3 years of historical energy cost data, and we did models. These are actual models with real heat pump data that we have. So these are real heat pumps that we took the data from and modeled them. And if you had to take that same exact house with the same amount of heat with these different heating types, what would it cost? So the most expensive one in here is electric resistance heat. That's like electric baseboards. Some people have electric ducted systems or electric like in ceiling heat. Does anyone have electric heat here? No, all right, great. because it's expensive. Propane, so propane and oil are delivered fuel, so if you don't have natural gas service, you probably have propane or oil. Who has propane or oil here? Okay, a lot of people. So you could stand to benefit from heating with a heat pump. So again, for the same model, and here's an air source heat pump, right? And looks a little weird, but this is kind of like, we took 3 of like fairly popular heat pumps and we did this model with them. So this is like taking 3 into account. And this is kind of the range it gave us. So between 1665, which is like this darker bar, and then up to 2224. So, it's modest savings, especially compared to oil, right? So it's not gonna like pay for itself in a couple years or anything. But, when the time comes where you need to replace one of these things, you can save a little bit of money with a heat pump. So again, modest savings, but, in an average year, you should expect to see some savings. And the cost of these fuels change all the time. Oil changes every day. If you boil oil, sometimes at the end of the day, it's a different price than the beginning of the day. So keep that in mind that like these prices bounce around. This is looking at averages, right? So in an average year, you'd expect to see some savings switching from oil and especially from propane. Natural gas is relatively inexpensive. It's you don't have to pay for delivery. It comes right to your house. We sort of like subsidize it on a national scale. But yeah, natural gas, you will not save money switching from natural gas to heat pump. So it's there are other reasons to get a heat pump: comfort, improvement, carbon emission savings. But yeah, I would never tell anyone to go natural gas. Like it's a good financial choice to switch your heat pump. But everyone weighs those things differently. So ground source heat pumps are very cost effective. So the basic thing with ground sources, they cost a lot more upfront. That ground loop we looked at earlier is expensive to install. But they are cheaper to run because they are taking heat from the ground all year round, and the ground stays the same temperature all year round, if you go down a few feet. So they don't have that same performance hit when it gets colder like air source does. So when air source heat, when it gets colder outside, again, they get less efficient. Ground source, because it's a stable temperature underground all year round, they don't have that same performance hit. So they are relatively inexpensive, right up there with natural gas. But again, it's it's expensive to install.
So on a house like ours that has ground well water, would they be able to repurpose or have some kind of a sink to the ground for using a ground pump?
That's a good question. I've heard of that working in some. I don't know. I don't know. I don't know the details of like what would make it work or not, but I have heard of people doing that. So I would talk to a ground source installer if that's something like and see how it would affect the cost of the project. I don't know if it'd be less expensive, and if so, how much. So I'm sorry, I don't know the answer to that.
So I have asked that for ours, and we'd have to drill a separate. You can't use the same well because you can't contaminate your risk.
Right, you don't want to risk
drinking
the water, but the idea of going straight down, we obviously have an area that's.
Right, but again, I think they need to be a certain amount away from the well
Okay.
to not hurt it.
Right.
And
Okay.
so it was the idea that like we were going to have to drill a whole separate well, and where can you do that on your property? And is that,
Right, so we have well in one yard, then we have a
Right,
septic in the other
exactly,
yard,
right.
so, okay.
So it's a tricky
And the
sort
bedrock
of
in the
thing.
warehouse.
Exactly, right. So I think there are, we were looking at the data the other day, I think there's like 16 households or something in Woodbridge who have the geothermal. So I would say, put it out in the community group, ask who's got it, find out like who they went with and what companies around here were able to do it.
Okay. Thank you.
Good question. All right. So we talked a little bit about sizing, so that was a good question earlier. So I would say if you're not in a position where you need to replace your heating or cooling system right now, a really great thing to get started with would be looking at the efficiency of the home first before you install anything new. So Hillary and Allison were earlier talking about the Home Energy Solutions Program. We'll talk a little bit more about that, but doing an energy assessment, and a lot of you have already done it, which is great, is a really great first step. So what they should be focusing on that energy assessment is the air sealing in the home, so how well sealed the home is, so you're not losing your heated or cooled air to gaps or cracks where it leaks out. And they should also be looking at insulation, so how well like that's like heat transfer through building materials. So both are important. And so the reason to look at this first is number one, it'll just help any heating or cooling system you have not have to work as hard. But also, if you're able to make improvements to the efficiency of the home, and that would reduce how much heating or cooling the home needs, you can potentially size any new heat pump or any new heating system smaller than you otherwise would have, and that could save you some money on your installation. So yeah, it's especially if you're not in a position where you need to replace something, really great first step for a home is the Home Energy Solutions program. I have another slide on that. We'll have a couple more details, but yeah, this is a great anytime, but especially before thinking about a heat pump. So we talked, thinking about goals with the heat pump, right? So, you could be in a position where you need to replace your whole heating system because it's broken, or like your service person told you it has not too much life left. That could be a goal because you need to. You could be looking for cost savings. So if you're heating with propane, maybe you're thinking about I've got 5 years left on this system or so, or you could install a heat pump and talk about this in the next slide. We'll talk about dual fuel. You could install a heat pump and keep your propane if you wanted. So even if it's not end of life, you could install it. You can have both. Comfort is a really big reason to get a heat pump. So if you don't have cooling, obviously you can get you get cooling with the heat pump too. So if you're already looking at air conditioning, heat pump installations are almost exactly the same as an air conditioning if you're going with the same design. It's just different equipment. So it's really, and sometimes with the rebates, it's actually about the same cost or cheaper to just install a heat pump if you're already thinking about air conditioning. So, comfort's a really big thing. Also, heat pumps provide a more even heating experience than other types of like furnaces or boilers, and that's because we talked about variable speed heat pumps earlier. So most furnaces and boilers and most air conditioners, especially older ones, are single or sometimes dual speed, right? So they are either on at 100% or they're off, or if dual speed, have like a partial load as well. But the variable speed, the fan has multiple speeds in the system, and the compressor has multiple speeds. So effectively, it's got like a few dozen speeds, some systems. And so, how a single speed system works is it actually waits until, say you want it to be 70. It actually waits till it gets to like 68, and then it fires up all at once and adds a bunch of heat in the house, actually overshoots 70, so it'll probably get up to like 72, and then it turns off, and it waits again, so you kind of like do this like sine curve with your temperature, so you're almost never actually at 70, which is kind of funny. But a variable speed heat pump, because they have those multiple speeds, to keep you right at like 70 or whatever temperature you want it could just bounce between those two speeds, just running all the time, or running at a lower speed ideally, to just maintain that temperature. So it should be a more even experience. I know Hillary said you're having some trouble with your controls, which is that's but in general, yeah, heat pumps are definitely should be a more even heating experience because of those multiple speeds, and reduce carbon footprint. So that's obviously a goal too. And these can all be goals, right? So heat pumps can accomplish all of these things for you. If that's what you're looking for. So, thinking about your older heating system, right? If it needs to be replaced, it needs to be replaced, of course. But if you have a lot of life left in it, if you've got, for those of you who have baseboard or radiant heating, the heat pump mechanically is not doing anything with those systems, right? So you can leave them in, and if they're working fine, you could leave it as a backup for the heat pump. In any case, you would, what makes it easier to operate the two together is called an integrated control. It's not really anything fancy, it's just a thermostat that connects to both systems. And that would effectively control how they work together, so you can set it up in a couple different ways. One way is really the most common way, is where it has an outdoor temperature sensor, and it'll say, okay, at 30 degrees, I'm gonna turn off the heat pump, and I'm gonna turn on the other heating system. And like we talked about earlier, heat pumps get less efficient when it gets colder, so there is a point, especially if you're heating with oil, where it's actually cheaper to use oil. So when you get down to like 20 to 25 degrees, it actually is cheaper to use oil compared to a heat pump, most heat pumps. So yeah, if you have a dual fuel system, switch over to oil at that cold temperature, and you're using the least expensive way to heat your house at whatever time, and prioritizing the heat pump when it makes sense to use it. You can also set it up to where the heat pump is the primary heat source, and you can just call for the backup heat if the heat pump, if you have like the most extreme max. So they should design, with that heat load calculation, they should design the heat pump to do everything you need down to the design temperature. And then below that temperature, sometimes they install like an electric resistance coil if you have a ducted system in the air handler, and that would add in a small amount of whatever the heat pump wasn't designed to provide, and that like 1% of hours that you'd get under the design temperature. That's very normal. But if you have two systems, you can say, I'm just going to use that, whatever, my baseboard for the backup on that 1% of hours. Or if you had a problem with the heat pump, it could always call for that backup as well. So really depends what you're designing for. If you're designing for a full replacement, or just like mostly for cooling and some supplemental heating. But yeah, you want to think about what's the life, how much life do I have if in my existing equipment? Am I going to keep it or not? Are important questions to think about when looking at a heat pump or any heating system.
Can I ask a question?
Yeah.
How does the hot water heater fit in if it's currently being, generated by oil?
Yeah, so we'll talk about hot water. There's heat pump hot water heaters. So do you have a combi boiler, which is like does your hot water and your baseboard hot water heating?
It's baseboard. I have hot air.
Oh.
I mean forced air.
So are they? But they're one unit.
But the furnace, heats the hot water.
Yeah. Okay. Right. So some people have like a furnace that does their heating and their hot water. So if you had that, like say you were going to do a heat pump and you only use that as a backup, you can keep that to do your hot water. So that would be one thing. But if you had like a separate like oil hot water heater, you could replace. We'll talk about heat pump hot water heaters in a second, but they're separate systems. So like the ones we're talking about for your house, don't do the hot water, but they're separate heat pump hot water heaters. We'll look at that. A little bit on zoning. So one of the advantages of ductless systems is that each ductless unit is its own zone. So you can kind of tailor the temperature to how you want it to be in the home. You can't have like 20-degree temperature differences between the different zones, but you can do, usually around like 5 to 10 degree temperature differences max, which is cool because you can kind of, if someone likes it cold, especially if you have ductless in each bedroom, you can kind of tailor the temperatures in each bedroom the way you want, which is nice if you don't have ductwork. And this is like not something you have to worry too much about, but if you have places where you prefer those temperature differences, thinking about that and working with the contractor is a good idea to help communicate your goals for comfort. So here we'll look at like an example floor plan, and we'll look at different designs that, and some make more sense than others. I should say. So, and this is not to scale. This is like way larger than it should look, but just had to make it big so it's obvious. This is a one ductless unit. So this would be like a single zone system. This is like a 1,500 square foot floor plan. And so this would be great for like heating and cooling this space, right? If it was sized through the whole space, it probably could be sized through the whole space. But even if it's just for partial heating, this could increase the comfort experience in this area of the home. And this is a relatively simple install. So this is like a single zone unit. It's going to be relatively inexpensive. You could probably get it all done with a contractor before any rebates in like the $4,000 to $7,000 range, which is pretty cool. So not super expensive, but this would not be well suited to do the whole floor, right? So you've got these bedrooms down the hallway. These are a little bit further away. And this would be like, sometimes this is the only way to do it, and I think oversized a little bit, I wouldn't call it so this can especially happen for small bedrooms where these ductless units that we talked, they come in half-ton increments, only get so small. So sometimes really small bedrooms don't actually need even the size of the smallest units. So this will work. This will heat and cool your house probably just fine. But right sizing the system is really important. So oversizing a system will hurt the performance, and it may hurt the comfort experience as well. So an oversized system basically doesn't do as well when you need like not a lot of heating. So on those low load heating days when you don't, or cooling days when you don't need a lot of heating or cooling, an oversized system doesn't do as well at those low temperatures. And actually, if it doesn't run as much so an oversized system will run less because it'll cycle on and off essentially. And if that's happening, sometimes it doesn't dehumidify as well as it could. And that's a really important part of comfort as well, is dehumidification in the cooling season. Anyway, so right sizing the system is important. Heat load calculations are important. And so, usually when you've got small bedrooms, a good compromise here is to do a combination of ducted and ductless, right? So this is a ducted unit in the attic. It's hard, this is like what they actually look like, so it's not really nice and bubbly with our chart here, or diagram. But, you can serve these multiple small bedrooms with one ducted system in the attic, and effectively you've combined them for the sizing, right? So it could be a more appropriate size for that space. And you could add a duct for like the bathroom or whatever here too. I've got another diagram that does have the bathroom duct on it. But anyway, this is kind of to demonstrate where these units work best in a home. So again, ducted is really great for smaller isolated rooms. Ductless is great for bigger open rooms here. And so, again, a lot of versatility.
Is there a relationship between the tonnage and the BTU output?
Yes, so 1 ton is 12,000 BTUs. So it's an exact conversion. So like, a 2-ton system is 24,000 BTUs, and 36, 48. And 5 tons is usually the largest residential units, so. All right, a little bit on just owner maintenance stuff, and we've actually got a heat pump user tips guide in the back, so if you have a heat pump or if you're thinking about one, you should grab that. But a little bit on maintenance. Clean the air filters, it's like true with any system, right? So, if you have a ducted system now, you're gonna swap that filter out every once in a while to keep the air quality high and to protect the system by keeping the coil clean. Keep the outdoor units clean and clear, right? So like, just don't want to like big leaf piles accumulate near the unit, around the unit, or they come in stands. So like snow and ice, you don't have to worry too much about that unless we got some crazy storm. But keep those clean outside. They should get serviced as well, annual service. So that's part of the service is to clean the coils for the indoor and outdoor units. So. Just like with any other HVAC system, definitely recommend annual service contracts. That's something a good contractor should offer to you after they do an install. Generally, $100 to $250, depending on what the design of the system there annually. Okay, so we had a question about heat pump hot water heaters. So these are really cool. They're just like, like any other type of tank water heater. So they've got the tank here on the bottom. And actually, this piece on the top here is the heat pump. So the heat pumps for your house that we've been talking about do the heating by taking the heat from outside, right? So they've got an outdoor unit. There are many split heat pump hot water heaters, but they're not the best in our climate right now, at least. But most of the ones that work well here are actually taking the heat from the air around them. So you would put this like in your basement or in a garage or in the space of the home that wasn't parked inside the building envelope, so usually a basement. And they actually take the heat from the air in the basement, which is interesting, and they actually dehumidify that air as well, because they're cooling the air, so by cooling the air they're taking moisture out. The moisture gets pumped outside, so you don't have to worry about it, but it's nice. So if you're already running a dehumidifier in your basement, kind of kill 2 birds with one stone with this. They produce just as much hot water. They are a little slower to heat hot water than other types of water heaters, but they make up for it because a lot of them have electric resistance coils. So like electric resistance and this like electric baseboard, it's like your toaster. It's turning the electricity into heat, so it's not very efficient because it's 1 for 1. All the electricity becomes heat. Whereas the heat pumps, because they're taking heat from from the air outside or whatever, because they're just moving it instead of creating it, they're a lot more efficient. So some of these have, they're hybrid. So they have the heat pump to do the heating most of the time. And then if you needed a lot of hot water all at once, like say you're taking multiple showers in a row, even though the heat pump is slower, it can call for that electric resistance coil to help heat the hot water a lot faster. It's less efficient. And you can get heat pump hot water heaters and turn off that feature so that it's only using the heat pump. So if you don't care about, I don't care if my water cools down a little bit in my shower, not a big deal to me. I want to save the electricity. You can turn on, you can go with the one with even that's not hybrid. So, but for those who are like power shower users, this is something I do that's not sustainable. Is I like my hot showers. I don't spend too long in there like some crazy people, but definitely a little bit longer than average, I would say, I shower. But yeah, you know, you can get the hybrid one if you want, or just one without the electricity going.
So these act like a regular tank, right? They hold hot water for
Yes.
hours on end. Okay.
Correct. Yeah, and that's like most of the time when the hot water is not being used, that's the heat pump is just maintaining that temperature in the tank. So that's why they're, you know, most of the time they're very efficient.
So it's just the recharge rate that's slow. Then.
Exactly. Yeah. But it's aided by that. If you have the hybrid, you can use that electric resistance, which is less efficient but faster.
Gotcha. Okay. Thanks.
How do these compare to what instant changes electric hot water?
Oh, good question.
Oh, for instantaneous electric hot water heaters is a lot more efficient because those are using electric resistance, which is the same thing this would use as like the backup for hybrid, but it's so per like amount of heated hot water, it's gonna be like 3 or 4 times as efficient as those. And actually when you're buying these, if you bought one of the ratings is called the UEF, Uniform Energy Factor. And that is like, it should be a number, usually like 3 or 4, and that is actually how much, a multiple of how much more efficient it is than electric resistance. So that if you had an instantaneous electric hot water heater, like a good UEF for one of these, yeah, it's like 4 is pretty good. So it's like 4 times as efficient as straight electric resistance, and so it would use like a quarter of the energy. But if you're comparing it to like a gas-fired instantaneous hot water heater, it's going to be around the same operating cost. So if you know, electric is way less efficient, but gas is about the same. Question?
So how long does it take for the water to get hot when you turn your faucet on?
Oh no, so it's maintaining the hot water in the tank all the time. So when I said it's slower, it's the recovery rate. So if you used all the hot water in the tank, it would be slower to recover all that hot water and be at like full. I haven't been used in hours, but like when you turn the faucet, it's just as hot as any other water heater in that moment. But if you exhausted all the hot water, it would take, you know, so I couldn't give you an amount of time, but it would take longer essentially. Does that make sense?
Yeah, so like after one shower, that's pretty much it? So you wouldn't be able to do kind of 2 showers in a row?
No, sorry, no. Like, it would have the same, like, assuming it was the same size as like a gas water heater or oil water heater, it would take the same amount of time. So if you had a 60-gallon tank, if it was a heat pump or oil, it would have the same amount of hot water, and you probably wouldn't use nearly that much in one shower. So, but people do recommend, so if you have have a house of 4 or 5 or whatever, that if you have a 60-gallon tank and you're already kind of like, it starts to not get as hot after like the 3rd person showering or whatever, just bump up the size of the tank anyway, and that could help to solve some of those if there were issues like that. Oh, sorry, there's a question next.
In answer to her question, theoretically she can get a mixing valve to keep the thermostat higher so
Yeah.
that the shower is using less from the hot water heater itself.
Right.
So you effectively get more capacity out of a lower or smaller unit.
Right. So what's your name, sir?
No, that was just
No, what's your name? Sorry, I was gonna.
Steve.
Steve. What Steve's talking about, yeah, exactly. So normally the hot water in a hot water heater is kept at like 120 degrees. That's normal, right? But what Steve's talking about is a mixing valve. You know, it would basically be an attachment to this. So when it's taking the hot water from the tank, it mixes in water from the street, and if you want it to be, you know, 80-degree water or whatever, it's going to mix in a certain amount so that the end result is you get 80-degree water on the tap. What Steve's talking about is what a mixing valve would do, you'd increase that to 140 degrees, so it's the same amount of hot water, just hotter, and then it mixes in the water, so effectively you have more heat in there, so you get more out of the tank, if that makes sense. So, yeah. Question right?
Yeah, quick question. So if you can heat water with a heat pump, why can't you use it for radiant heating? Baseboard, in-floor heating, you know?
Yeah.
And just convert, because we have radiant baseboard,
Right.
it'd be so easy just to convert it to that, right?
Right, and so, great question. So there are air to
Air,
water,
water.
heat pumps. They're not very common, and they're, especially in our climate. So in short, the air to water heat pumps can't get the water as hot as a boiler does. So the base, especially for, this is true of baseboarders, if you have cast iron radiators, they're built to work on with a certain temperature, it's in a range usually, but a certain temperature of water. And so based on the surface area, or the surface area of the radiant heating and the temperature of the water, it's calculated to deliver a certain amount of heat, match with how much heat the home needs. And with the heat pump, because it can't get it as hot, and we have like because of our the American style baseboards, and especially cast iron radiators as well, they just don't deliver as much heat, so they really can't be used for it. European style radiators have much higher surface area, and so those can work. If you have radiant in ceiling heating or in floor heating, you obviously don't want that to be as hot, right? So they can work with those, just not the baseboards, unfortunately. But technology is moving really quickly, and there are some systems now that can do it, but they're not very common. They're expensive. It's hard to find installers, and you'd be like a really early adopter.
But theoretically, you're saying you could use the European style radiators? Or no, not yet, not quite yet.
Right, and the problem, I mean, you could do it. I think the problem would be finding contractors who are experienced in that equipment, at least at this point right now. But if in theory, if you have them, yeah.
So wait 6 years.
It won't be too long, but yeah, I mean, 6 years. Hey,
don't
6
they
years
work the
doesn't
same?
feel like I was still in college 6 years ago. But
Well, I mean, we did the electric car back when they only had 48 miles on
Right.
the charge on
Right.
the, Honda Fit, so that was like, 6 to 10 years ago.
There's-
The early adoption, yeah.
There's
Now
a
we
big
got 300,
opportunity.
400 miles, so,
right.
yeah.
I wouldn't be surprised if they're more common or in that little time too. So.
Okay.
So my general question before was just like, so my oil fueled hot water heater has a recharge rate of 13 minutes, right, to get up to full capacity. Do you have like a general comparison, like these would take 30 minutes, like, or like any kind of?
I don't know off the top of my head, but all the manufacturers do have that. Like that's like part of the data that's in the equipment. But I'm sorry, I don't have a good approximation. Sorry. I just know it does take longer though.
Okay.
And then I saw one other. Was there one other person?
It's a more general question. So this was all, the discussion's all sort of house-centric, right? And I'm just wondering, is there any work being done for community very, very large community geothermal systems for the outdoor part of the heat thing that we were talking about earlier, that either like could heat and cool all of our town buildings right here in Minnehaha Lane, or could do a neighborhood, or could do like High School, you know what I'm saying? Like, so it's not just one house doing this, but like say 20 houses together, or a village like this, where I mean, obviously you're going to have all the individual units in the different buildings, but one great big geothermal, because that's the expensive thing, and it seems like there'd be cost savings, and it would be, the hassle factor for everybody doing all of that individually is huge, and there's a big sort of thing that people have to get beyond. So I'm just wondering, is there any talk of that? And is it feasible, or do you lose a lot of the energy when it has to travel? Or what's the deal?
Yeah, great question. So what you're talking about, and you can Google this later, it's the term that's most popular, I would call it's called district geothermal. So there are experimental projects that are happening in New York and in Massachusetts around district geo. Connecticut, as far as I know, is not working on anything at like the utility scale, but I know that in conversations I've had with like people at the state level, I know like some towns are doing this with like certain town buildings and then like schools. So I think that there's like on some campus, one of the state campuses, they have like a few of the buildings connected. It was one of the, it might have been Eastern or Western or yeah, one of those. But so there's like it's experiments are happening where I think like there is a future where a lot of people envision this as like a utility scale, like the same way we get electricity delivered to our house. Instead of getting fuel delivered, you get heat delivered, right? So there's a community network of like a pipe that has, you know, the salt. It's in geothermal salt water,
Right.
so it'd be like certain temperature salt water, and you like either draw from or give to the thermal grid. Where you see the most advantage of those types of projects is where two things, where you have one, either, or both of these things, right? Where you have buildings with some that need cooling and some that need heating, right? So a good example of this is where you have like an ice rink, or you have a supermarket which has a lot of refrigeration. So a cool future could be where you've got a supermarket connected to like a neighborhood nearby, and the supermarket's always going to need cooling, right? And those buildings are going to need heating sometimes. So those two things, you could swap where one needs heating and one needs cooling, instead of moving it outside. And so if you both had heat pumps, one is taking heat and moving it outside, the other one's taking heat from the outside, you know, so they could basically swap their needs. So that's one way that those projects, the feasibility and cost savings definitely go up. The other is where you have mixed usage profiles. So this works well with like office buildings and homes, where like you've got in the office, for a commercial office building, all the energy use is during the day, right? So everyone's there in the office, they need cooling or they need heating at that time because everyone wants to be comfortable and they want productive employees. But homes, like when everyone's at work, that's like the time when there's the least energy usage, at least during the week. So if you swap, you know, that way you can build a system that only has to meet the peak load across those different usage profiles, instead of a system that has to meet the peak load for each individually all the time, if that makes sense. So, yeah, I would say Google. There's some cool projects that are happening, but none here, unfortunately.
Go to Iceland or something.
Yeah.
In terms of municipal projects, in Madison, they have geothermal for their library, and in Branford, the main fire station has a geothermal heating and cooling system as well, and they're looking into it for the police station redesign as well.
That's cool. I love that.
So does it make sense though if a municipal building is already natural gas? Is it, because you showed those cost comparisons,
Yeah.
would you dig geothermal if you're already in gas?
It depends. I mean,
Sounds
it depends how the town
oil,
uses it.
yes.
There's other challenges with gas too, like there's a certain risk factor. Like, you have a burning thing in your house, in your building. You don't have to worry about like if you have a cracked heat exchanger on your gas system, there could be like unspent fumes is leaking out. So you don't really have the risk of that, which is, I guess, nice.
But cost-wise,
I mean, it wouldn't. You wouldn't. It would be similar energy expense. Like if you looked at it, there's a very small difference between gas and so I guess the town would have to weigh like what's most important to them. You know, they get cooling and heating. So if you're doing a lot of cooling and a lot of heating, like you kind of life cycle of the equipment, right? So when we're looking at the big scale of those projects, like everything's super expensive, so it's easier to justify, I guess, at a larger scale too. So yeah, it's gonna be like project by project, I would say. All right, I'm gonna move forward. I love all the questions, but I'm gonna get us to the end of this, and then I'll stay around. We can answer anything else. But so resources. So home energy solutions. We talked a lot about it already. It's a great service. There's an income eligible version as well. So that you get rebates for what they recommend. So if they recommend attic insulation, you can get a rebate for it. With the home energy or with the income eligible version, they pay for everything. So if you are income eligible, definitely for anyone, but definitely for income eligible, I totally recommend looking into this further.
Could I make a quick comment there?
Sure.
The wise use is not a good system. People have had a lot of problems with that. If you're interested in this, go through the Heat Smart program that the town will be bringing out, and they'll send you to independent contractors that are approved by the utility, but they will see to your needs. I'm sorry, but wise use is,
It's a different team at Eversource. Or at the utility. By the way, I work for a consulting company we're Energize CT behind the scenes is like utilities, and then like groups like mine help like run parts of the work.
I'm sorry, that was a terrible comment I made, but
We appreciate the
Very
honesty.
helpful.
Editorial.
Well, I think part of that is because, so at least my experience with calling the wise use is you just get put randomly to some company. And so I've had 2 energy audits. They were both very, very different. I had 2 very different experiences. So one was absolutely fantastic and they did so much work and I can't believe that I didn't have to pay for any of it. And then the second one was highly disappointing. So I think that's kind of where HeatSmart is getting, they're a little bit more curated, perhaps.
yes, the HeatSmart program has been run in multiple towns, and PACE has worked with selected contractors, and the good ones have risen to the surface, let us say. So go with HeatSmart.
Better watch your energy bill next month.
You can control
I'm gonna go change the computer. No, I'm just kidding.
Can you turn it down as
No.
well as that?
Brad did it, but no, I totally different. I don't even work at the utility, so I don't know. I don't get that. Just okay. So heat pump rebates, right? So there's a rebate from Energize Connecticut. So you can get, it's based on the size of the system. So we talked about tonnage earlier. So for air source, it's $750 per ton. For ground source, it's $1,500 per ton. We have a qualified product, so there's efficiency requirements. You don't have to worry about that. Just tell your contractor I want to get the rebate. They should know what's on the list. You don't have to. You can look at it yourself if you like Excel. You're more than welcome to. But don't worry about that. The only exception, so you can get this. The only exception is if you're replacing an existing heat pump. Unfortunately, you can't get a rebate for that. So sorry if you have an existing heat pump. Goal is to get people to switch to heat pump. So that's that. Okay, Inflation Reduction Act. This was passed in 2022. I'm sure a lot of you are familiar with this. So we'll go over some of the stuff related to this. So number 1, this is available today, and this is the tax credit for heat pumps. So it's 30% of the project cost, up to $2,000. This is straight from the Energy Star website, so you can go here, and they have a Find a Products tool as well, because there are efficiency requirements for this too, so you want to pay attention to that. But again, contractors should know what's eligible, or at least if they don't know, they should go find out. So you're just saying, you know, when you're talking about your goals, saying, hey, these are my goals for my home, but I also want to make sure I can get the rebates and the tax credits that are available to you.
Those are dependent on income though, I think.
This is not. Neither of the things we mentioned are neither dependent on income. What I will say is that, like, if you don't owe any taxes, then you can't take advantage of this. So in some ways it is dependent on income, because if you made no income, you would owe no taxes, and then they can't credit you anything back that you never owed. So, but they don't have income minimums.
Oh, okay.
If you're talking the Inflation Reduction Act, there's other. We'll talk about that in a second. There's an income. There isn't. This is okay. So there's more from the Inflation Reduction Act. There's more. That's on the way. It's not here yet. So this is a map from the Department of Energy for the Home Energy Rebate Program. So this is like part of the inflation. So the Inflation Reduction Act, there's 3 pieces for home energy credits. One was the tax credit we looked at. There's other tax credits too. The 2 other pieces are both on the way still. It's federal money, but each of the states will be implementing it at the state level. So our state energy office, which is DEEP, Department of Energy and Environmental Protection, is working on their plan for rolling out this program with the Department of Energy. So you can kind of see on here, this blue, this turquoise color is application submitted. And Connecticut is in the application submitted phase. So they've created their plan for the money, how they're going to use it, and they're going to, the DOE has some guidelines, and the states can be flexible under those guidelines with the money. So beyond the limits that DEEP set, we really don't know too much about what Connecticut's going to do. They haven't said much. They got this public round of public feedback, I think 6 months to a year ago. But beyond that, we don't know the plan. So there is stuff coming. We don't know much about it. It could be up to $8,000 per household. There are income limits. but by definition, most households will qualify. It's the minimum. There's 2 income brackets. The higher one goes up to 150% of the median income. So by definition, most households should be in there. But we'll learn more probably in the next couple months. I hope. So this is changing almost every day. So I check this thing all the time. I only updated this like a couple weeks ago, or maybe a week ago. So there may be others that have changed from this, but yeah, we're right along there, moving along.
So should we all wait to do anything until we
I don't
start?
know. Well,
We
yeah,
won't be able to get it after the
Right.
fact if we make a contract, right?
right, and what I will say too, and I'm going to limit, not to get political at all. I'm going to limit. Please don't want any other conversation about this, to be honest. But the incoming administration has named the Inflation Reduction Act as something that would be on the chopping block in the goal of cutting government spending. And the only reason I bring it up is because they've said it by name. So I don't know what will happen with that. I don't know what can happen. I don't know if it's too late. I don't think anyone has the answer to that. So beyond that, I just would want anyone who is thinking about this, if you're thinking about waiting, just to be aware of that. I don't know if that'll happen or not. And like, if it does, that's the way it is. But just be aware that like you might want to wait because it could be a lot of money, but at the same time, I don't know. Some states already have it available, so maybe it's too late because they already have the money. I don't know how the government works like quite intricate at that level, but like how these programs get rolled out. So I just point that out because it's something that I would want anyone to be aware of if you were thinking about if you're planning for this money. You know what I mean? So.
Usually the wheels of government turn very slowly.
It's true, this passed in 2022, and we're only getting it now, 3 years later, so that's absolutely true. Okay, so financing options. Oh, I should have taken this off. Okay, this is going away at the end of the year. I'm sorry to say, I should have removed it from the slides. This was created, this is a really low interest loan, it's really awesome product, but it was created by a piece of legislation, another government thing. It was created by a piece of legislation 10 years ago, or I think, or so. And that, in the legislation, it was set to expire at the end of this year. And here we are. So it's going away, unfortunately. If you are very, very determined, you might be able to get a heat pump project application through this program by the end of the year. So you're more than welcome to try. It's, again, really low interest rate, but yeah, unfortunately it's ending at the end of the year. Not all fuels are eligible for this, so if you have natural gas, you're not going to be able to get this loan. The project has to be savings positive. And even some oil projects like only get partial financing, so just be aware of that. The Smart E-Loan, this is not going away. This is going to be around for a little bit. Oh, I forgot to update this. This changed, so the interest rate's higher now, unfortunately. It's between 7 and 8%, not 6 and 7.5%, so it's a little bit higher because interest rates have risen in the last, well, now they're coming down if you follow the Federal Reserve. They are coming down, but slowly. And so, anyway, up to $50,000, up to 20-year term. You don't need any money down. The microloan is great. This is really meant for, in conjunction with the Home Energy Solutions program. So you do that energy assessment, and anything they recommend, including heat pumps, can be used for this loan. So it's 0%, but it's only up to $3,000. It works best with like insulation, because most insulation projects would fall under this when you add the rebate in. But yeah, you can use it for part of a heat pump project as well, assuming you did the Home Energy Solutions program. Any questions here?
Is the rebate from Energize CT dependent on having a Home Energy Solutions visit?
No. So for the insulation, yes, but for the heat pumps, no.
Okay, thanks.
All right, great. And so like I mentioned earlier, at any point in the future, y'all can go to our website, or you can scan this right now if you want. But we do heat pump consultations that are like, and hopefully you've learned a lot tonight, but we can talk specific to your home, like what your goals are, design-wise, what might make sense, what to think about with contractors, questions to ask. We also got a questions for your installer guide in the back you should grab if you're interested. But yeah, happy to speak with you more about your home. I'll stick around too. We can talk a little bit about your home too. But a lot of those conversations take a long time, and I really want to give you the time, or whether it's me or one of my teammates, I want to give you the actual time. So having the time booked out with a consultation is a really good idea, just because we can take as long as you need to talk through your house, make sure you feel educated and comfortable going into getting quotes and stuff. Oh, also in this, we do quote comparisons too. So if you do get quotes, we can talk about any design differences. We can look at performance data, talk about performance differences. We'll never say like pick this one or that or whatever. Our goal is to just do like apples to apples comparisons, so you can see for yourself what might make the most sense for you. We have a qualified contractor list, so our heat pump installer network. It's a great resource. They have to be on the list to offer the rebate, so you want to check it out. We make sure they're insured, licensed, and have done some trainings, but it doesn't tell you whether they're awesome or just average contractors on the list. So I would definitely cross-reference this with other due diligence, like reading positive reviews online, finding positive reviews. Heat pump manufacturers have their list of contractors that they recommend, who sometimes do better trainings, they install more heat pumps, sometimes they get better warranties, so like looking at those manufacturer lists, cross-referencing that with this list is a good idea. And here's some other resources. Some of the stuff I printed in the back. I've got the user tips guide back there. I've got the questions for your installer guide. I've got this quality installation checklist. But we've got a bunch of other stuff, guides to different, even stuff beyond heat pumps, different types of equipment here. There's like a consumer buying guide down here linked. So this is all right on the website. If you go to energizect.com/cleanheatcool or energizect.com/heatpump, you can find all this stuff there. And any other questions?
I'm a consumer buying guy. They happened to be in Lowe's the other day, and they're selling a do-it-yourself heat pump kit for like $1,700. Mr. Cool. Any input on that?
Yeah. So you're asking the question is about DIY equipment. Like Mr. Cool is one of the really popular brands for that. Yeah, I would say so. Pros and cons with DIY, right? Like it's a lot cheaper. So the biggest pro is that you're going to save a lot of money. Some of the highest performing heat pumps, especially for cold temperatures, are not DIY. So like we could find Mr. Cool has all their data published. So if you are trying to decide should I DIY, should I not, we can do comparisons, right? And if you're looking, especially at cold climate performance, often the professionally installed equipment only is going to perform a lot better, especially at cold temperatures. But yeah, other things with DIY is that you don't really get a service contract. You don't have someone who installs the services, so it's harder to find people to service it, keep it clean, to make sure it's going to live its full life. And then also no warranties. Well, they do have warranties usually, but they're less. With a professional installer, they usually give you a 10 or sometimes 12-year warranty. So that's you take a little bit of hit there on the warranty. But
You don't get any rebates on it.
you don't, unfortunately. I think you can get a tax credit though if it meets their requirements, which I'm not sure if I haven't looked at whether the DIY ones often do or not. But. Anything else?
Yeah, how much intelligence would be in a system, like for example, we pay ridiculous electricity costs in Connecticut. Like we're like peak off peak, and we're like 54 cents a kilowatt between noon and PM. We have 2 electric cars that we can only charge during off peak because of that. It's cheaper to go to a charging station than it is to charge from the house. And we have oil heat, but I was just wondering, we also have solar, which helps us in the summertime with our air conditioning, but in the winter not so much. Is there any intelligence or whatever settings or whatever that could help us switch between what is our most efficient source for heating, like between our oil versus between the heat pumps during the winter time? I'm not so much worried in the summertime because we get so much from solar, but not so much, and especially during peak, off peak, or just in general, depending on what the cost of, And I heard UI is increasing electricity rates again.
Yeah, no, we have one of the most expensive rates in the country. If you look at like a map, like
Yeah.
New England especially, but Connecticut, yeah, it's crazy. Sorta. So yes and no. I mean, so the integrated controls we talked about are pretty smart with the heat pump and the oil. So if you add the two systems, like generally, I mean, it makes the most sense to switch over between like 20 and 30 degrees because that's when heat pumps become less efficient than oil when you look at average costs. But if you know, like, we can do them in a consultation. Like, we can actually take the heat pump you're getting recommended, and we can do like a model of the performance over a season. And that will tell us, and we can even plug in like your oil usage history too.
Okay.
And that will tell us, like, based on the performance data of the heat pump, and it tells you how efficient it is, all these different temperatures, and we can calculate like where it's called the balance point, where oil is going to be cheaper than the heat pump, and we can basically tell you that, and that gives you some information. As the prices change though, right, those are gonna change.
Right.
And then
But electricity doesn't do anything but go up.
yeah, right. So yeah, I mean, in terms of based on the rate, I really don't think they're not smart enough to know if you have, you know, a peaks or not. Like all utilities are different with the way they do their rate schedules. So yeah, they're not really. I mean, if you know, like, hey, during the day I want to reduce my energy usage, like, you could have it set up on the thermostat to adjust your temperature lower during the day. But I will say with heat pumps, it actually is doing like setbacks at night. A lot of people like turn the thermostat down at night. It's actually less efficient to do that with a heat pump because they have to basically working really hard to get you back up in the morning eats away all your savings and then some a little bit. It's not like a huge. It's not going to matter a ton if you are way more comfortable when it's colder at night. Keep doing it. But if you're doing it to save energy, you're actually not with the heat pump. So I wouldn't make like a huge temperature adjustment. But if during the day you want to turn it down a couple degrees, as long as it's not like a greater than like 4 or 5 degree temperature adjustment, then it's not going to impact the performance too much. It might save a little bit doing that. But.
So now, to his question, there actually are programs which you can put in the temperature or the cost of your oil, the cost of your electricity, and it will then say, okay, we're going to use oil more, we're going to use electricity more based on cost. So there are programs, they're generally for commercial operations as opposed to home operations.
Okay.
But there are programs that exist that do that.
Thank you, Eric. I was gonna say there's probably some fancy thermostats that will do that, and I would imagine like on the commercial building scale, it totally makes sense to like have a building management system that can do that. But yeah. Anything else, everybody? Great questions, by the way. I really appreciate it. All right. Well, thank you for listening to me. Thank you so much.
Thanks everybody for coming. On your way out, you'll walk by. There's a whole bunch of clothes there. Feel free to look through. It's our winter wear free cycle. There's probably more smaller sizes, so if you know anyone with kids, grandkids, anything like that, absolutely look. Coats, hats, scarves, everything's out there. All for the taking.